Hello, my name is Greg, and I am a tutor with Chegg Tutors. And today we will just be talking about a couple, which is a term used in mechanics. So mainly used in your statics classes, dynamics. So what a couple is essentially just two parallel forces that are equal in magnitude, opposite in direction, and do not share a line of action. So as you can see here in this first example here, we have a straight bar with two forces acting on the ends of it. As you can see, the forces, they are parallel. They are essentially equal in magnitude. They're the same length. They are opposite in direction. As you can see, one points to the right, one points to the left, and they do not share a line of action. So that is what a couple is. Here are some examples of not couples, essentially. So in this first part, we have a bar where the arrows are the opposite direction and they don't share a line of action, but they are not equal in magnitude. As you can see, this one is represented by a shorter line, this one is represented by a longer line, so magnitude is not equal. The second one, we have equal in magnitude. They don't share a line of action, however they are not opposite in direction. They both point to the right. And for this last one, we have they're equal in magnitude. They're actually not opposite in direction, but they do share a line of action. As you can see, these forces are acting along the same line, which is considered the line of action. So this does not qualify as a couple. So now, what is essentially the use for a couple? What a couple does is it produces rotation about a certain point, and it does not allow for any translation. Meaning, if this bar, as you can see, we have two arrows, two forces acting in opposite directions. This bar will only rotate about that red dot in the middle, the pivot point. So it'll rotate like in this direction, in the counterclockwise direction. This bar will not translate up or down. It will not move up, it won't go to the left, it won't go to the right, it won't go down, because these forces just allow it to just rotate about one point. Now, if this blue arrow here, let's say this blue arrow was replaced with a force like this, then yes, there would be translation, because this force is greater than this force, so it would essentially kind of slide the bar up a little bit. There would be some rotation, however, there would be a little bit of translation. Now, to get rid of that translation, we just make sure that the two forces in the couple are equal in magnitude, like this. So essentially, since it's rotating, the couples are generating a moment about a point. Now, to calculate that moment is really simple. The equation for moment is equals force times the distance from the pivot. So first we calculate the moment from this first blue arrow. That would be F times L over 2, because that is the distance from this, the point that the force is acting on from the pivot. That's a distance of L over 2. So that's creating a moment of L over 2. Plus, there's another force here acting away from the pivot. So we do another force times, and again, distance from the pivot from here to here is L over 2. So that this whole equation here is equal to the entire moment generated by the two forces. And couples can really be anywhere on the bar. I drew it in these examples that I've shown. I've drawn the arrows to be on the very edge of the bar, but they could be right here. It could be, and there could be another one right here. Now these are equal in magnitude, they don't share a line of action, and all this does is that it creates a moment about essentially the midpoint between the two forces. So it would create a moment right about at that point right here. We have an equal magnitude, it's opposite direction and does not share a line of action, so it does create a moment about that point. And all you'd have to do is just calculate these forces multiplied by the distance from the point to the force, multiplied by this force, or added to this force times the distance to this pivot point here, which is what we did here. So that is really what couples are all about. I hope it's all clear to you. If you have any questions, please feel free to message me, and I hope you have a great day.